This is SpaceTime Series 29, Episode 68, full broadcast on the 8th of June 2026. Coming up on SpaceTime, how black holes shape the cosmos, NASA forced to end its MAVEN Mars mission, and planet Earth gets a rare blue micromoon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has revealed how powerful jets generated by black holes have shaped the universe. The findings, reported in the journal Nature Astronomy, are based on measurements of the jets emanating from Cygnus X1, a system made up of the first confirmed black hole and a blue supergiant star. The authors found that the power of the jets in Cygnus X1 was equivalent to the power output of 10,000 suns. Black hole jets provide an important source of feedback to the surrounding environment, and they're critical to understanding the evolution of galaxies. Located some 7,300 light-years away, the black hole in Cygnus X1 has around 21.2 solar masses. While its stellar companion is a variable spectral type O blue supergiant of about 40 solar masses. The pair orbit each other every 5.6 Earth days at an average distance of 0.2 astronomical units. That's about 20% of the distance between the Earth and the Sun. The Cygnus X1 system appears to belong to a stellar association called Cygnus OB3, and that would mean Cygnus X1's probably around 5 million years old. And, like its binary companion, was formed by a progenitor star that had more than 40 solar masses. These arise from gases being accreted onto the black hole from the blue supergiant and then heated to extremely high temperatures. To make their measurements, the authors used a radio telescope interferometer. Interferometers link up multiple observatories around the planet, and this gave the astronomers the resolution they needed to measure the immense power being generated by the jets from the black hole. And the authors observed the black hole jets being buffeted by winds from the companion blue supergiant as the black hole moved around it in its orbit, much like strong winds on Earth will push around water in a fountain. By knowing the power of the wind and measuring how much the jets were bent, the authors could determine the instantaneous power of the jets for the first time. And they were also able to determine the speed of the black hole jets to be about half that of the speed of light, 150,000 kilometres per second, another measurement that had challenged scientists for decades. The study's lead author, Steve Prabu from Curtin University, says he was able to make the measurements using a sequence of images of the dancing jets, a term he used to describe the jets' movement patterns as they were repeatedly deflected in different directions by the blue supergiant's powerful stellar winds. Prabu says the measurements allowed the authors to understand what fraction of the energy released around the black hole was likely to be deposited into the surrounding environment, thereby changing that environment. Prabu and colleagues found that around 10% of the energy falling towards the black hole was being carried away by the jets. Previous methods could only measure the average jet power over thousands or even millions of years, preventing accurate comparisons with the X-ray energy released instantaneously from the infalling matter. Prabu says astronomers can now use this measurement to anchor their understanding of the jets, whether they're formed from black holes 10 or 10 million times the mass of our Sun.
Cygnus X1, it is the first widely accepted confirmed black hole within the astronomy community, and there was even a wager between Kipton and Stephen Hawking back in the 1970s if they thought the system could actually have a black hole. Over the last few decades, it taught us a lot regarding black holes and jets and how they can influence their surrounding. And even though we understand a lot regarding the source, we have few open questions. So that's when 3 years ago, we started looking into some of these high-resolution radio images of the black hole. And that's when we saw that the jets were actually bending because of the star that's orbiting the black hole, and it's got really massive, strong winds that can actually push the jets around and make it appear as though it's dancing. And we also found it's actually the equivalent of 10,000 tons. And then we also had few other key measurements of the source.
Roughly speaking, about 10% of the material falling onto the black hole is thrown back out again in the form of these jets.
Yes. That is actually a very important measurement. So black holes have something called as an energy budget, like how we budget our income into different things. So black hole also has something called as an energy budget. So there is energy going to the black hole because of the material falling into the black hole, but then they can budget it to different things differently. Some of it can get eaten by the black hole. So trying to understand what percentage of the infalling material or energy gets converted to jets is like a very important measurement. So that's what we found to be around 10%. So in literature, within astronomy, because the number has been ad hoc assumptions, they've determined that number in like literature, but there was never like a direct evidence of it. So this is the first time we have like a direct observational evidence of it.
Because all black holes are basically the same, you can use those observations to extrapolate onto other black holes as well, bigger ones and smaller ones.
Very, very true. Yes. So like I like to imagine that using Earth, Moon, and the Sun. So we know the Moon goes around the Earth, and then there is like orbital motion of the Moon around the Earth, and we can apply Kepler's laws, and you can actually take the same physics and scale it up to Earth and the Sun. Though like the masses are different, you're just scaling it up, and the same Keplerian laws apply when Earth goes around the Sun as when the Moon goes around the Sun. So similarly, you can take this 10% energy budget of the black hole and scale it up to supermassive black holes. And the reason that is very important is because in every galaxy, at the center of it, there is a supermassive black hole that can weigh a few millions to billion times the mass of the Sun. These jets are launched like very, very large jets, and the jets from the supermassive black holes can deposit lots of plasma and magnetic fields in the mediums between galaxies and surrounding galaxies. And that heavily influences how like galaxies and the large-scale structures in the universe evolves over time. So that in these large-scale simulations, that energy budget of black holes is like a tunable number that they play around with, and then they set it to like 10% because of their models. But our detection actually puts it on like very strong observational sounding, and it's like robust now.
How did you carry out the observations?
So we use this two instruments actually in our study. So one is called the VLBA, Very Long Baseline Interferometry, and the other is called European VLBI. So essentially these two telescopes are like lots of telescopes spread within a continent. So VLBA is in the US and EVN is in the Europe, and multiple telescopes spread across the continent. They work together and synthesize a very high resolution image in radio frequencies. So it's a slightly smaller version of the Event Horizon telescope that made image of the black hole in our galaxy and M87 like 2 years ago. So it's a slightly smaller version of that. So the Event Horizon telescope scales the size of the Earth. Our telescope spans the size of the continent. So we use those two instruments to make very high resolution images of the black hole jet. And yeah, we were able to study it in very high resolution detail.
Do we know how the jets themselves, these beams of matter and energy coming out of the black holes, do we know how they're created?
We had like theories on how black holes launch jets from like 1970s and 80s. So the black hole has material falling towards it because the black hole is a very dense point in space. Another point about black hole being is that they can also spin. So because they spin, they can warp and they can twist the space-time around them. So we call that frame dragging. So because of that effect, the black hole tends to warp and twist all the magnetic fields in its vicinity into like a helical field along the axis that it's spinning. And these magnetic fields are responsible for launching of the jet. So essentially, it taps into like the spin energy of the black hole to launch the jet, to create the magnetic field which launches the jet.
And you're able to confirm also the speed at which the jets are moving out from the black hole.
Yes. So because the jets were bending, it opened up like a new way of studying the black hole jet, and that this new method that enabled us to measure the speed of the jet as well. So we found it to be traveling at like half the speed of light. So that's like a lot of material carried away from the black hole at the speed of light, and hence producing the energy equivalent of 10,000 tons. The jets that to set the scales, the jets that we detect, so the black hole itself is around 100 kilometers. So 21 times the mass of the sun compressed to a size of 100 kilometers, and the jets launched from the black hole span the size of our solar system, to set things in to set the scene for the system.
Where would you like to see this research go next?
So there are a few other systems where there are similar massive stars orbiting either a black hole or a neutron star. I think Cygnus X1 is probably the easiest, lowest hanging fruit that you can apply this technique to. But there are other systems with similar massive strong winds and black hole jets from like either black holes or jets, neutron stars that we can apply similar techniques to. So I might have a look at like similar other systems to see if we can also estimate like their powers and jet speeds and other system parameters.
That's Dr. Steve Prabu from Curtin University. And this is Space Time. Still to come. NASA forced to end its MAVEN mission to Mars, and planet Earth gets a rare blue micromoon. All that and more still to come on Space Time. This episode of Space Time is brought to you by NordVPN, Spacetime's official VPN service. Let's face it, these days your online privacy is more important than ever. Whether you're streaming science documentaries, reading the latest research, or exploring deep space images, you don't want your data to be tracked or your location exposed. With NordVPN, one click is all it takes to secure your internet connection. It encrypts your data, hides your IP address, and keeps your activities safe from prying eyes, whether you're at home, work, or connected to a public Wi-Fi. And here's where it gets really good. As a Spacetime listener, we have an exclusive offer for you. 74% off a NordVPN plan plus 4 extra months for free. That's right, a huge 74% discount plus 4 bonus months just for being a Spacetime listener. All you need to do is head over to nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. Not only does NordVPN protect your data, but it gives you access to content from right around the world. If you want to watch a science series that's only available in another country, no problem. Just switch your virtual location and unlock it instantly. And of course, the whole thing is risk-free with a 30-day money-back guarantee. So you've got nothing to lose and your online freedom to gain. So protect your digital life, support Spacetime, and grab our exclusive offer now at nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. NASA has been forced to shut down its MAVEN mission orbiting Mars following a mysterious failure aboard the spacecraft back in December. The probe suddenly went silent on December the 6th as it was passing behind Mars. Attempts to re-establish the signal after it came around the red planet's limb back into view of the Earth were unsuccessful. The Mars Atmosphere and Volatile Evolution, or MAVEN spacecraft, was the first mission devoted to observing the Martian atmosphere and evolution. It's been orbiting Mars for 11 years. The agency convened an anomaly review board in February to try and evaluate recovery efforts and assess the spacecraft's probable current state. And the review board's now determined the MAVEN spacecraft cannot be saved. It's not recoverable, and it's no longer capable of performing its science and data relay missions. Telemetry from MAVEN prior to the spacecraft's passage behind Mars in December showed all its subsystems were working nominally. But after the spacecraft emerged, NASA's Deep Space Communications Network did not receive a signal. A brief fragment of telemetry data from analysis of radio signals recorded by the Deep Space Network's open-loop receivers indicated the probe was in a safe mode, but was rotating at an unusually high rate when it emerged from behind Mars, indicating a disruption in MAVEN's orbital trajectory. The review boards concluded that due to this rotation, the batteries on the spacecraft had now drained, causing the communication system to lose power and rendering MAVEN as unrecoverable. Now, these preliminary findings don't address a potential root cause for the anomaly that's still being investigated. The review board's now expected to provide its final report later this year. The science MAVEN gathered has provided valuable information about the kind of radiation protection and safety measures will be needed before the first humans are sent to the red planet sometime in the next decade. Launched back in November 2013, the MAVEN mission explored the red planet's upper atmosphere, its ionosphere, and the interactions between the atmosphere and the Sun in order to investigate the loss of the Martian atmosphere into space. Understanding atmospheric loss gives scientists insights into the history of the planet's atmosphere and climate, liquid water, and planetary habitability. MAVEN discovered that the erosion of the Martian atmosphere increases significantly during solar storms. Scientists studied how the solar wind, that's the constant stream of charged particles flowing out from the sun, and solar storms, which are more powerful bursts of particles, continuously strip the red planet's atmosphere. And this provides a key insight into how Mars was transformed from a warm, wet world, potentially capable of supporting life, into the sterile, freeze-dried desert it is today. And MAVEN was the only spacecraft that could simultaneously take measurements of both the Sun and the Martian atmospheric response. It discovered several types of Martian aurorae that light up when energetic particles plunge into the planet's atmosphere, bombarding gases and making them glow. MAVEN showed that the protons create new kinds of aurorae on Mars. On Earth, proton aurorae only occur in very small regions near the poles, whereas on Mars they can occur anywhere. To better understand how Mars lost most of its atmosphere, MAVEN measured atmospheric sputtering for the first time on any planet. It observed argon, which is a noble gas, meaning it rarely reacts with other constituents in the Martian atmosphere. The only significant way argon can be removed is by atmospheric sputtering, a process where ions crash into the Martian atmosphere at high enough speeds so that they splash gas molecules out of the atmosphere, much like doing a cannonball into a pool. Astronomers used 11 years of MAVEN data to show the presence of sputtered argon at high altitudes in the exact locations where the energetic particles crashed into the atmosphere, showing sputtering in real time. In 2018, a series of Martian dust storms created a dust cloud so large it enveloped the entire planet. MAVEN then studied how this global dust storm affected the upper Martian atmosphere in order to understand how these events affected the escape of water into space. It confirmed that heating from dust storms can loft water molecules far higher into the atmosphere than usual, leading to a sudden surge in water lost to space. And it doesn't end there. MAVEN also contributed to NASA's efforts to observe the interstellar comet 3I Atlas. Over the course of 10 days last year, MAVEN observed 3I Atlas, taking multiple images of the comet in multiple wavelengths, including high-resolution ultraviolet images, to identify the hydrogen coming from the comet. By studying a combination of these images, scientists can identify a variety of molecules to better understand the comet's composition and history. During the mission's lifetime, MAVEN's science team produced more than 800 publications, and additional publications are in the works now as the backlog of data is processed. In addition to its science work, MAVEN was also a key part of NASA's Mars Relay Network, communicating data from the Mars rovers back to Earth. In fact, it holds the solar system record for the most data relayed from another planet in a single day. And so, it's farewell to MAVEN, a spacecraft which will be sorely missed. This is SpaceTime. Still to come, planet Earth gets a rare blue micromoon, and later in the science report, paleontologists have identified fossils of a new species of raptor-like dinosaur in South America. All that and more still to come on SpaceTime. Skywatchers have just experienced a rare blue micromoon. The title comes from the fact that, well, it's a blue moon. Mind you, that's got nothing to do with the moon's colour. It refers to the rare event when a second full moon occurs in the same calendar month. However, technically, that's not quite accurate. In astronomical terms, a blue moon occurs when there's an extra full moon in an astronomical season of 3 months, the period between equinox and solstices, which would normally only have 3 full moons. And due to the way the lunar cycle aligns with the solar calendar, a season may occasionally have 4 full moons. And so the third full moon in that 4-moon sequence is what's referred to as a blue moon. Now, as for the micromoon part of the title, well, it refers to the moon being at apogee, that's its most distant orbital position from the Earth. The moon's orbit around the Earth isn't circular but elongated, and when the moon's at its furthest from the Earth, it looks an itsy-bitsy bit smaller and dimmer than normal, hence the term micromoon. Now, on this occasion at apogee, the moon was some 406,135 kilometres away. That compares to the average Earth-moon distance of 384,400 kilometres. The opposite is the much heralded supermoon. That's when a full moon happens while its orbit's closest to the Earth, called perigee. And the most recent supermoon was back on December the 4th last year, when the moon was just 362,312 kilometres away. Now, for the technically minded, during the recent micromoon event, our nearest celestial neighbour appeared to be about 6% smaller and 10% dimmer than that of an average full moon. Of course, in real life, that difference is extremely subtle. Most people wouldn't have noticed it. And even if you knew, you probably would have needed measuring equipment to tell the difference for sure. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization has again confirmed that an El Niño climate event is expected to develop this month, and they now say it's expected to last until at least the southern hemisphere spring. An El Niño event can bring hotter, dry conditions across much of Australia, driven by warming sea surface temperatures in the tropical eastern Pacific. The World Meteorological Organization says there's now a 90% certainty that this pattern will develop in coming months, bringing an increased risk of extreme climate and weather events across a large part of the world. A new study claims that up to 1 in 6 cases of COVID-19 might have resulted in patients suffering long COVID. The findings, reported in the Journal of the American Medical Association, investigated some 458,000 patients with COVID-19 across 58 hospitals in the United States. And the authors found long COVID occurred in 16.28% of all cases. They also found that almost 90% of these long COVID cases were representative of chronic conditions, meaning that 9 in 10 people with the condition had it for extended periods of time, usually 6 months or longer. The World Health Organization says over 7.1 million people have been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. 28,000 deaths were caused by the virus in Australia. The Lancet Medical Journal estimates that the true global death toll is likely to be more than 18 million, with over 750 million confirmed cases globally. Palaeontologists have identified fossils from a new species of raptor-like dinosaur uncovered in Patagonia. A report in the Journal of Vertebrate Paleontology claims the 3-metre-long fish-eating archosaur would have behaved a lot like modern-day herons. The dinosaur has been named Canc australis. It was identified based on teeth, vertebrae and toe bones. It's related to a family of small to medium-sized theropod dinosaurs that have been discovered from the late Cretaceous period in Australia, South America, Antarctica and Madagascar. It lived more than 70 million years ago in the landscape of meandering rivers and streams with seasonal ponds inhabited by aquatic plants such as water lilies and animals including fish, insects and mollusks. A new study has shown that many so-called anti-vaxxers eventually change their mind and get the jab after all. A report by researchers at Imperial College London found that nearly 2/3 of people who initially expressed reservations about the COVID-19 vaccination were eventually vaccinated during the campaign. The Skeptics' Tim Mendham says the study found that reluctance was highest early in the campaign. He says in January 2021, 8% of respondents still expressed doubts about vaccination, but by early 2022, that figure had fallen to only around 1%.
Basically, it's saying that a lot of people who were hesitant to get vaccinated when the COVID outbreak first occurred later went and got vaccinated. They actually looked at a huge number of people, over 1 million people. They had records to see, obviously they had records of people who had been vaccinated. They looked at those who hadn't been vaccinated from the first outbreak and who later did get vaccinated. Now, so we're saying in January 2021, 8% of respondents to their thing expressed doubts, but by early 2022, that doubt figure has fallen to 1%. Now, in any vaccination population profile, you're going to get a majority of people are vaccinated. They understand it's worthwhile. They understand it has proven benefit. You get a small percentage of people who can't get vaccinated because they're medically compromised. You get the people who are hesitant. I don't know. And they suggested that people are hesitant for various reasons. There's one survey that said a lot of women are hesitant because they don't know what's in them or they think it's going to affect them personally, like their ability to have babies, that sort of thing. Little kids don't like them because they don't like needles, and if they men don't like them because they don't think it's as big a problem as it's being made out to be. So a lot of the people who are hesitant eventually do get vaccinated. So there's a huge number of people who don't get vaccinated do. There's still also that other little cohort of the population who are the anti-vaxxers. And it doesn't matter what you say to them or what evidence you put forward, they won't get vaccinated. And they sadly encourage others by spreading fear and misunderstanding and misinformation about what vaccination is and what it can do. And why? Because they're just pain in the backside.
How much of that is a problem of journals like, well, in this case, the Lancet Medical Journal? They allowed Wakefield and people like him to spread their lies for years.
Yes. I mean, it's not just the popular press and the TV shows and things. The Lancet, a recognised learned journal.
It was more than a decade before the Lancet retracted the story, even though they knew it was wrong.
Yes, they did. It took a hell of a long time to do that. Andrew Wakefield, with a number of other people, wrote an article suggesting there might be issues with the MMR, the measles, mumps, rubella vaccine. The fact that Andrew Wakefield was working on an alternative vaccine was beside the point. They had issues with the vaccines. Wakefield then said in publicity for this thing, and there's a lot of publicity, that the MMR vaccine can lead to autism. So a lot of parents, especially in the UK, Wakefield was stopped vaccinating, and then suddenly, therefore, there was outbreaks of measles, mumps, and rubella, which are, can be fatal. So because of this guy making these claims that it could lead to autism, thoroughly debunked, no foundation for the theory. It's been so widely tested. I think in Denmark they tested 1 million people or something. It's a hell of a lot of people. There's no evidence at all that this has an impact on autism, but the papers covered it. The Lancet had published the original paper. Most of the people who were co-authors on the paper withdrew themselves when they realised what Wakefield was doing, but the Lancet didn't want to withdraw the article, at least not for about 10 years or so. Wakefield was eventually struck off the list of doctors, went to America, where of course he made a fortune, and has become a martyr to the cause of the anti-vaxxers. And the trouble is, the ones who suffer most of all are those people who are medically compromised. You need a large percentage of the population to be vaccinated. 95% is basically it, which just leaves that small cohort of people who can't get vaccinated.
And here in Australia now, there are some places where as few as 80% of the people are vaccinated.
Some places where it's down to 60%.
Wow.
Especially in the sort of free-thinking, liberal, hippie sort of areas.
Nimbin.
Yeah, whatever. Byron Bay sort of areas, that sort of thing. In a lot of places in the world, so these people are having a big impact. You're currently seeing a rise of measles cases in the US, in the UK, in Europe, in Australia, and it's because of the low vaccination rates. It kills hundreds of thousands of people every year, especially in third world countries. And it's all because of people who are anti-vax, influencing people who are hesitant about vaccination for whatever reason, and the ones who suffer are those who can't be vaccinated.
That's the Skeptics' Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.